1, 0. Hi, I'm Lee Easton, one of the online tutors here at tutorhero.net. Today I'll be giving a finance demonstration, so a demonstration of our online tutoring for finance. First I'll introduce myself. I come from the economics PhD program at UC Berkeley. Before that I studied mathematics and philosophy at the University of South Carolina. And I cover a variety of subjects, as you can see from this list. And if I don't cover the subject you want, then we have online tutors available in most likely your subject as well. So we have online tutors available for most subjects at the undergraduate level, and we offer tutoring at levels ranging from high school level all the way up through PhD level, MBA level, master's level. So we can help you with a variety of needs. So today we're going to be demonstrating my tutoring on a problem in finance. Just so you know, we're using my actual online classroom. So this is what things would look like and sound like if you were getting tutoring from me. So here we're going to be doing part of a problem involving calculating the net present value of an investment. So what does net present value do? Well, basically net present value is a way of converting a complicated string of information into a single number. So when you're thinking about making an investment, well, you're going to be spending money today. Maybe you're going to be spending money for a while. And then at some point in the future, you're going to be getting money back. Now, money today is not like money in the future. They're different things. So we need some way to aggregate all of that information into one thing so that we can make our kinds of investment decisions. And that's what net present value does. So in this problem, we have a project that requires an initial investment of $50,000, and that's happening today. And the project is going to start paying off benefits. So $10,000 in 1 year, $20,000 in 2 years, and $30,000 in each of the following 4 years. And we're also told that the correct discount rate, adjusted for risk for this investment, is constant over the time frame, and it's going to be at 8.2%. And they also tell us that the profits are going to be received at the end of each year. So basically that's just a way to simplify the problem for us so we don't have to worry about adjusting for half years or anything. So the first step of almost any net present value problem, and the first step of this problem as well, is to draw a cash flow diagram. So what does a cash flow diagram look like? Well, you're going to start with a line. So this line is like a timeline, and you're going to go through at each time period where something happens, and you're going to indicate it. So at the start of the problem, something happens, and what happens? Well, you spend $50,000. So you are going to be at, let me type this in, so minus $50,000. So that's at time we often call time zero, or today. So that's the first cash flow that occurs in this problem, is you spend $50,000 on the investment. And we're going to draw that below the line to indicate that it's negative. We also wrote a negative in front of it just in case we forgot that. So then what happens after that? Well, the next thing after that occurs at year 1. And so we'll put a box here, and we're going to say that the next thing that happens is $10,000, and that occurs at year 1. So that's the next thing that happens. What happens after that? Well, at year 2, we're going to get $20,000. So we're going to put another box here, and we're going to indicate that $20,000 will occur at year 2. And what happens after that? Well, in year 3, we're going to get some cash flows as well. So in year 3, what are you going to get? Well, they tell us in the problem that you're going to get $30,000. And similarly, for years 4, 5, and 6, we want to go ahead and put it all on the graph so that when we're going through the next part of the problem, we're not confused at all about how the cash flows are coming into the problem. So that's why you always start with this kind of diagram you're doing one of these problems is that you want to make sure that you understand precisely what the structure of the investment is. So it's very helpful to have this kind of diagram and to be able to look back. And if you ever get confused when you're solving the problem about when things are occurring or how much to discount something by, then you can go back and look at your cash flow diagram and be able to say, oh, okay, that happened in year 6, so I'm going to discount years. So a cash flow diagram, when you're completed with it, should look something like this. It may not be as nice if you're drawing it on a piece of paper. If you have unlimited time to produce it, it may look even nicer, but it should end up something like this. And that's the starting point of all such problems. Now, the next part of the question, this is the last part that we're going to do, is to calculate the net present value of this investment. And obviously, we produced the cash flow diagram first so that we could understand how to do that. So I'm going to write out a formula here, and it's not going to look very formulaic. It's just going to tell you basically what net present value is. So net present value is the sum of all cash flows discounted by how far into the future they occur. So what do I mean by that? Well, basically, for net present value, you take the cash flow and you discount it according to when it occurs, and you do that for each separate cash flow, and then you add them all up. So in particular, what is the appropriate discount rate? So the appropriate discount rate, so let me type this out for you. So the appropriate discount rate is 1 over 1 plus the interest rate raised to the power of the number of years in the future that event is occurring. So 1 over 1 plus the interest rate to the number of years in the future that's occurring. And this interest rate actually doesn't have to be an interest rate. It's whatever the appropriate rate of discounting is. So let's go back to our problem here and figure out how to apply this formula. So what is the net present value here? Well, basically, you start at time 0 and you go forward. So to start with, what do we have? We have minus 50,000. And how do we discount that? Well, we don't discount it because it's occurring at time 0. So when you plug into this discount rate formula, and so we can, just for completeness, we can go ahead and do that, right? You're going to get 1 over 1 point, and to go back up and look at our interest rate again, 1.082. But that's going to be raised to the 0 power. And so that means that this whole thing becomes 1. So year 0, it's just going to be minus 50,000. For the next year, you get $10,000, and you're going to multiply it by the appropriate discount rate, which is 1 over 1.082. Again, you could raise that to the 1 power, but raising something to the 1 power just leaves it by itself. And then after that, what are you going to get? Well, you're going to get 20,000, and you're going to multiply that by 1 over 1.082 squared. And what about after that? Well, you look up at your cash flow diagram again. Year 3, $30,000. So the next term that's going to go in here is $30,000 times 1 over 1.082 to the third. And then we're going to have 3 more of those, right? Year 4, year 5, and year 6. And they're going to go the same way. So $30,000 is the payment, and it's discounted by 1 over 1.082 to the number of years in the future it occurs. So I'm running out of space here, so what I'm going to do is go down a little bit and keep adding. So year 5, you get another $30,000, discounted by that to the 5th, and Finally, you get one more payout in year 6, $30,000 times 1 over 1.082 to the 6th. So that is your net present value. And all that's left to do is to punch that up into a calculator and add it up. So the key to calculating net present value is to understand how do you add it up? How do you get the right formula? And so the free cash flow diagram tells you how to do it. So you start at the start of the cash flow diagram, you're minus $50,000. Then after that, you have your $10,000 in year 1. You discount it by the 1-year discount factor. After that, $20,000 in year 2, discounted by the 2-year discount factor, and so on. So every term in your net present value sum should correspond to a point on your cash flow diagram. So all that's left is to add it all up and get the precise numerical answer. And I'm going to trust that you can do that on your own. So I hope that this has been helpful. I hope this has been a good demonstration of how net present value is calculated and what it means. Net present value, again, is a way to rank different investments. If this investment came out to have positive net present value, then it would be a good investment in the isolation. If you had competing investments, you would want to compare the different net present values. Whichever one had the highest one would be the best investment. So once again, this has been a demonstration of how finance tutoring can work in the online classroom. I cover a variety of subjects, and if I don't cover the subject you need, we have a variety of other talented tutors who are able to help. So come visit us at tutorhero.net, email us at tutor@tutorhero.net. If you're not sure which tutor is the best tutor for you, send us an email, and we'll help you sort everything out and find the person who's going to be the best person to meet your needs. All right, so I hope you found this helpful, and feel free to contact us if you have any questions. Thanks.